Alright, hi everybody. We are looking at 1.8, Interpreting Graphs of Functions, on page 56. I'm actually going to give you guys a handout, so some of the stuff you'll mark directly on your handout, and then when I write on notebook paper, you'll write in your notebook. Oops. Alright, so let's get started. Okay, read your goals here of this lesson. First one is interpret intercepts and symmetry of graphs of functions. And we'll get to the longer one later. This is going to be a two-part lesson probably because this is a long section. Start by reading your definitions here of x and y intercepts. To interpret the graph of a function, estimate and interpret key features. So the intercepts are some of the key features. The intercept of a graph are the points where the graph intersects an axis. Okay, so notice intercepts and intersects, they sound very similar, so that can help you remember what it means. Okay, the y-coordinate of the point where the graph intersects the y-axis is the y-intercept. The x-coordinate of the graph is where the graph intersects the x-axis. Okay, and hopefully you remember y-intercept from y equals mxb as well. And b was where the graph intercepted the y-axis. Okay, so that can help you remember that here. And then the other thing you're going to need to know in example 1 is linear and nonlinear. Okay, we'll go ahead and write all those definitions down. And your notes should look like mine, so go ahead and write all this down, including the definitions of these two. Linear, just like it sounds, the root word here is line. In math, when we say line, we mean a straight line. Okay, so a linear graph forms a straight line. Nonlinear does not form a straight line. Continue your video when you're ready here. All right, example 1. Okay, have a look at that. We're looking at this graph here. First it asks us, is it linear or nonlinear? Okay, and you can look at that and see that it is clearly nonlinear. Okay, switch out my notes here. It is nonlinear. This is clearly not a straight line, so it's nonlinear. All right, and then it tells us to estimate and interpret the intercepts. Okay, so look at your graph and ask yourself, where does the graph cross the x-axis? If you look closely down here, I'm covering up the answer, I jotted down already, looks to be at about an x of 7.4. Okay, so your x-intercept there is 7.4. If you look closely over here at the y, looks like the y-intercept is about 15. Okay. Sometimes we list points, typically we list points as ordered pairs, but the y-intercept and the x-intercept are kind of unique. We know that the y-intercept will occur at an x of 0, and so we usually just write y-intercept equals 15 instead of writing the ordered pair 0, 15. Same for the x-intercept. We automatically know that the x-intercept will always occur where y is 0 because it always occurs on the x-axis. Okay. So those are your intercepts. And now we need to interpret those. And this just takes a little bit of practice. It just means explaining what they mean. So to do that, you need to study your graph, study the title, and the y label, and the x label, and that helps you out. So we see this is height of a launched object. Okay, and this point, the y-intercept, means at time 0, the y, or the height, is about 15 meters. So that sounds a little awkward. So we might say something like, the object started at a height of 15 meters. At time 0, that's another way to say it started. The height, right here, was about 15 meters. Okay, and then over here, this says at a time of about 7.4 seconds. Then you look to see what this is, height, y. At 7.4 seconds, the height of the object was 0. Another way that we would say that in more clear everyday language would be the object hit the ground at about 7.4 seconds. Okay, so that's example 1. Let's see, we will just kind of underline and highlight the important stuff here instead of rewriting it. We have that it's nonlinear because it's a curve and not a line. Y-intercept is 15. Means that the object started at an initial height of 15 meters above the ground. Then X-intercept, 7.4, object struck the ground after about 7.4 seconds. Okay, good. Let's do one more. Look at this next one, and then unpause your video. And I do actually want you to jot down whether or not it's linear, non-linear. Tell me what the X-intercept is. Tell me what the Y-intercept is. And then interpret them, meaning describe what that means in real life. And unpause your video when you're done. Alright, so you can see that this graph is a straight line, so that makes it linear. And then we need to estimate and interpret the Y-intercept. The X-intercept. Okay, so the X-intercept is where the line crosses the X-axis. That's about right there. So you read all the labels on the graph. This is about a sample that we're thawing. This is time in hours and temperature in degrees Celsius. Okay, so the X-intercept occurs at about 1 hour. And the Y-intercept occurs at about -5 degrees Celsius. Alright, so the X-intercept is 1 hour, the Y-intercept is -5 degrees Celsius. That is telling what they are. Now we need to interpret them, which means to just describe what they mean. Okay, so this point is at 1 hour. The temperature is about 0 degrees. And let's see. In this case, I guess it would make more sense if you talk about what happens as time goes on. So let's actually talk about this one first. Okay. So at time 0, when you click your timer, when you start this experiment, when you start thawing the sample, right here at time 0, the temperature is -5 degrees. So that's a good starting point. Okay, so let's say the sample was initially, that means at the beginning, -5 degrees Celsius. Okay, and then after 1 hour, the temperature is 0 degrees. Okay, so that's explaining what that means. After 1 hour, the sample, we could say it was 0 degrees, or it had warmed up some to be 0 degrees. Sample had warmed to 0 degrees Celsius. Okay? And that is interpreting and describing what the intercepts mean. Alright. Alright, moving right along here. I'm on the top of page 57 now. Okay? The graphs of some functions exhibit another key feature, symmetry. A graph possesses line symmetry in the x-axis or some other vertical line if each half of the graph on either side of the line matches exactly. So that's very wordy. It's kind of hard to describe that verbally, but it's not hard to see it. Okay, but go ahead and write that definition down. All right, and then let's look at example 2 here. I guess we should underline what's important on our handout as well. Okay, and then example 2. An object is launched. The graph shows the height y of the object as a function of time x. Describe and interpret any symmetry. So if you look at this graph, this is the graph of the line. Okay, they've added this line of symmetry. Okay, and that's what you are going to do when you're doing these problems on your own. You can see that if I fold my paper along that line of symmetry, that dotted line, and I folded the graph over like this, it would match up exactly. Okay, so you want to be able to place that line right where it divides the graph in half. Right, if you folded your paper along that line, the graph would match when you fold it over. Okay, so the right half of the graph is a mirror image of the left half. And this line right in the middle, you kind of want to look at the peak of the graph, or sometimes it'll be a valley, but you can see that peak happens right there. And so that is where your vertical line goes. If this is 2, this is 4, that means this is 3. That occurs at about 3.5. Okay, so that's how they get this. The right half of the graph is a mirror image of the left in approximately the line x equals 3.5. And it's symmetrical between x is 0 and x is 7. Okay, note x equals 3.5. That's how you name a vertical line. Vertical lines are named x equal and then whatever value that is. Here about 3.5. So in this particular situation, that means that it took the object the same amount of time to go up as it did to come down. Because I'm saying the space between here and here, 0 and 3.5 seconds, matches this side, 3.5 to 7 seconds. Okay. All right, that's it for this video.